Okay, hello everyone. This is part 3 of NMR spectroscopy, and we're going to be looking at two isomers, two ketones. Now, let's draw it out so we have an idea about what we're talking about. We've got pentanone, which means there is a carbonyl group on the second carbon, and the rest is hydrogens. Now, we need to think about how many different hydrogen environments there are in this molecule. And this depends a lot, as we will see later, on symmetry. Okay, if we look at the NMR, although it's quite small, we can see that there's 4 different peaks. Okay, and that means there's 4 different hydrogen environments. And if you look at this molecule, it is not symmetrical. Okay, and therefore each hydrogen on each carbon is a different environment. For example, these 3 are one hydrogen environment. Now you might think that the CH3 group on the other side looks very similar, but it's not, because it's not close to an oxygen, and therefore it feels a different magnetic field than the hydrogens here that are so close to this carbonyl group. Okay, so this CH3 group will appear higher on the scale, on number 2. And for example, it's this one here. I'll mark it with blue. Okay, let's put a 1 there. Now, the second environment is this one here, and it's quite far from the carbonyl group, and therefore it is quite low on the scale. And number 3, we can think about this one here, which is a bit closer to the carbonyl group, so needs a weaker magnetic field than environment number 2. So this is environment number 3. And finally, we have, let's think, environment number 4. This is now also very close to the carbonyl group, so it might be somewhere here. Just checking. Yeah, okay. In higher level, we will see why there's multiple peaks, but now we're just focusing on the standard level. So pentanone will show 4 peaks. Now, if you do the integration, it will give you the number of hydrogens per environment, but watch part 2 for an explanation of that. Now, pentanone has 4 peaks. Let us look at pentanone. Pentanone only has 2 peaks, so it's easy to distinguish between the 2 isomers. Pentanone has 2 peaks because it is symmetrical. The carbonyl group is on carbon 3. So that means you only have 2 hydrogen environments. The ones on the side and the ones in the middle. So let's just use our color scheme to help us out here. So these 6 hydrogens are all the same because they're at the same distance from a carbonyl group. And they are this peak here, the first one. Let me fix that. And the second hydrogen environment is closer to the hydrogen, the carbonyl group, and therefore appears at a higher ppm, so a weaker magnetic field. Now, this is the power of NMR. We have 2 isomers, which would have the same MR and the same infrared spectrum, more or less, because they would both have a peak at 1700 centimeters to the -1. Watch the video on infrared spectroscopy for an explanation of that. So it's so easy to distinguish between these 2 isomers, pentanone and pentanone, based on just the peaks, just in the hydrogen environments in the 2 isomers. Something you cannot do in an infrared and not so easy to do in mass spectrum. Well, I would like to acknowledge ChemGuide, an excellent website, and of course the database of the NMR spectrum.